Okay, graphing rational functions. I'm going to do a series of videos here. That way this video doesn't end up being 20 minutes long. I'm going to give you a basic intro right here, go over one different thing, and then we'll start talking about it. So first of all, what a rational function is. It's when you're going to end up with the same thing we've been working with, where we've been adding, subtracting, multiplying, dividing, basically fractions with variables in them, okay? So what we're going to look at are problems like this. All right, and we're going to figure out how to graph these things. Now, there's a lot of stuff that we have to be able to do with this. First, we're always going to factor them, okay? We're always going to factor these and try to figure out what's going on. Once we factor them, the things we're going to be looking for, we're going to be looking for holes in the graph, a place in the graph that the graph does not exist. It doesn't have an asymptote there or anything like that. It simply does not exist, and we'll talk about how we get holes. We'll be looking for vertical asymptotes. We will be looking for horizontal asymptotes. And we'll also be looking for slant asymptotes. Okay? And then once we find all those different things, we'll look at how to graph these. All right? So there's a lot that goes on within this, but I'm going to break it down in a bunch of different videos for you. That way you can go back and look at each video and reference each video if you have any issues while working through it. All right, so what we're going to do first is we're going to deal with the function that I just gave you. So that's x squared plus 4x plus 3 over x squared plus 5x plus 6. And label this holes. Okay, so we're going to discuss how you find holes in the graph. So the first thing we're going to do is factor this. So something that multiplies to give 3 and adds to give 4. Multiplies to give 3, adds to give 4. So that's going to be 3 and 1. So we factor it as x plus 3, x plus 1. On the bottom, something that multiplies to give 6, adds to give 5. Well, that's going to be 3 and 2. X plus 3, x plus 2. All right, so we factored. That's always going to be step 1. Now, the way that we identify a hole. A hole is where factors cancel. So if we have a hole, it's going to be where factors cancel. And you can look at this problem and say, well, they cancel right there and right there. The x plus 3 cancels. So to find the hole, we're going to take the factor that canceled, x plus 3, set it equal to 0, and we're going to solve it. So subtract 3, x equals negative 3. So there is a hole in our graph at x equals negative 3. Okay, again, right now all I want you doing is going through, finding all these different things. I will show you how they show up on a graph. So there's a hole in the graph at x equals negative 3. Where factors cancel, it creates a hole. So now what's left over with our function? Those canceled. So our new function is now x plus 1 over x plus 2. Okay, so after the factors cancel, we end up with an entirely different graph that we're going to actually end up dealing with. Okay, so the x plus 3 is canceled, leaves us with x plus 1 over x plus 2. Let's look at one more problem. What I want you to do is pause this video, factor the top, factor the bottom, and then see if you can find any holes in this problem. So pause the video, see if you can find a hole. All right, hopefully we factored this. Top is going to have a GCF of 4, so we factor it out. 4 times x plus 1. On bottom, we're looking for something that multiplies to give negative 3, adds to give negative 2. So we're going to do x minus 3, x plus 1. All right, now once we have it factored, we analyze and see if we have holes. Does anything cancel? Yes, those two cancel. So we take it, we set it equal to 0, x plus 1 equals 0, x equals negative 1, so that means we have a hole at x equals negative 1. So that's an intro to rational functions and also how we find holes in the graph.